All right, this is question 8 of section 2 of the math proficiency test. So it's asking us, it gives us tables. It gives us this question of an amusement park charges an entrance fee and a cost per ride as shown in the table. So this is our table here. We're given a number of rides. If I have 3 number of rides, the total cost is $15. If the number of rides is 9, our total cost is $27. So it's asking us what is the cost per ride. So what we have to first figure out, and we know that our total cost equals our entrance fee plus our our number of rides, because it depends on number of rides. So we can also say that equals our entrance fee. We can let it be, let's say our entrance fee here is X. We don't know what entrance fee is, plus our number of rides, and that's going to have another cost, right? So, or you can say number of rides times cost per ride. So we can say it's number of rides. So let's just say it's n here in this case times cost per ride. So let's just say it's y. So this is total cost. So this is total cost. So just say capital T here. So we have this algebraic expression. We have t equals x plus ny. Now let's plug it into our first table here. If our total cost here is 15, so we can say it's 15 for our total cost equals our entrance fee, which we don't know, plus n, which is number of rides, right? We said n is number of rides, and y. So we have our first algebraic expression here. Our second one here is we can use our second table, right? We have here total cost is 27 equals entrance fee, we don't know what that is, plus 9 number of rides times y, right? So now we have 2 algebraic expressions, and what we can do with that is we can actually use this concept of substitution. So I'm going to rearrange my first equation so I can isolate for one variable. So let's say I'm going to isolate for x because I want to solve for y, right? Y is my cost per ride. So in order to do that, I would have to do, I'll actually rewrite this. So I'll rewrite this here. So this is 15 equals x plus 3y, and 27 equals x plus 9y. So I'm going to isolate I'm going to work with our first equation here and isolate that first. So let's do another color. So if I have 15 equals x plus 3y, I want to isolate for this x here. So I'm going to move this 3y to the other side, right? So if I'm adding 3y to this side, I have to subtract 3y on both sides to get it to the other side. So 15 minus 3y equals x, right? I'm subtracting 3y from both sides, so it gets rid of 3y on this side. So now I have my equation here, right? So I can also write this as x equals 15 minus 3y. And now I can actually do this concept of substitution. So I can you can think of this as equation 3. I can sub this into my second equation for this x value, right? So what that means is I can rewrite now. I can say 27 equals x, which is actually this term here, 15 minus 3y, plus 9y, right? And now what I'm going to do is I'm going to isolate for y, right? So I have 27 equals 15. So I have here minus 3 plus 9. So minus 3 plus 9 here is positive 6 y. Now I can subtract 15 from both sides, so I can get rid of 15 on the right side here. So I have 27 minus 15 equals 6y. I'm going to continue my work on this side. So 27 minus 15 here is 12 equals 6y. Now I can divide both sides by 6 here, which would give me y equals 2. So my cost per ride here is $2 per ride.